In our previous lesson, we said that we identify the nature of turning points using these criteria. Now today we have a question here which we also want to determine its nature of turning point. We have to describe the nature of the turning point or points of the curve y is equal to 2x cubed. First thing we do is to get the gradient function or the first derivative. So the derivative of this, that's dy over dx, is equal to, you take this 3, multiply by it here, so you'll have 3 times 2x, then reduce 1 from the power, you get it squared. So the derivative will be 6x squared. Then we know at turning points, the value of the derivative is always equal to 0. And for that reason, we shall say a turning point dy over dx is equal to 0, meaning equate this one to 0. 6x squared should be equal to 0 because that's our dy over dx. If we do that, you can first start by dividing both sides by 6 to reduce the magnitude of the number. So we shall have 6 over 6x squared here is equal to 0 over 6. And that means x squared is equal to 0. Now, if x squared is 0, then it means we need to get the square root on both sides so that we can get the value of x. And if we do that, if we get the square root on both sides, we shall say root x squared is equal to root 0, meaning x is equal to 0. So that means this is the x coordinate of the point, or of the point where we expect the turning point to be. We only have the x coordinate of that point. We don't have the y coordinate. For us to get the y coordinate, take this x coordinate here that we have calculated, substitute it in the equation that we had, y is equal to 2x cubed, so that it will help you get the y coordinate, the corresponding y coordinate for this x coordinate. So if we do that, we shall say when x is equal to 0, y will be equal to 2x cubed. As I've said, our x is 0, so y will be given by 0 cubed, and that is 2 into 0, giving us 0. That means the y coordinates of this x coordinate that we have identified to have a stationary point is 0. That this 2 gives us the point 0, 0. So that is the point where we expect the turning point to be. Now we have identified the turning point, but we don't know whether it's a local maximum point, local minimum point, or a point of inflection. And for that reason, then, inspection is necessary. And for us to achieve that, we need to get the second derivative. So how do we get the second derivative? We differentiate the first derivative that we have calculated up here, this one here. So we shall say d squared y over dx squared, that's the second derivative, is equal to the derivative of the first derivative. And if you differentiate this, of course, you get 12x. So that means d squared y over dx squared is equal to 12x. Now, we have the turning point as 0, 0. Take the x coordinate, which is this 0 here, the left 0. Substitute it here. If the final result gives you a positive value, then it means that is a local minimum point. If it gives you a negative answer, it means that's a local maximum point. But if it gives you 0 or infinity, that means that's a point of inflection. So if we substitute this 0 here, we shall say when x is equal to 0, then d squared y over dx squared will be 12 into 0, which is 0. And what did we say when we get the second derivative being 0? We said that is a point of inflection. Therefore, we can say this point here is a point of inflection.